Alright guys, so we have some Magnetron, and this goes into your microwave, and we're going to test this one. Now, when it's bad, your microwave will not heat, and sometimes it will make a weird noise. So let's check it. So get your meter out and turn your meter to resistance. Have that little bell or volume thing, and when you touch it, it should beep. Okay, so now we're in continuity. So what we're going to do, we're going to touch these two leads together, and you should get a reading. Okay, usually you want to get less than 1 ohms, like 0.6. We do have these on, so those can increase your resistance. Keep that in mind. Okay, so we're at 07. Still a little high, but not bad. But there's another way you want to check it. So now we just check the winding on the inside. Now we're going to make sure that the windings are not touching the body. So the windings are not supposed to be touching. So if you touch the body and you hear a beep, it means it's bad. Anywhere in the body. Okay, now you may not hear a beep, but that means you're still getting continuity, meaning the winding inside is now touching the body. Probably touching that as well. Yep. So this is a bad magnetron. Now, another thing that goes with the magnetron, and it's called a diode. And what the diode does, it sends electricity from the capacitor to ground. This would be attached to the microwave and the body of the microwave with a screw. So what happens when you open the door, it discharges the capacitor, sends it to ground. So it's the same thing when you're working on a microwave. You want to be careful with those capacitors. They do pack quite a bit of voltage, 2100 volts. That can definitely stop the heart if it's long enough, so you want to be careful. So you also need to test this. Now, when you test these, you want to get your test lead in one end. I'll show you shortly. Like that. And the other end. Now, from here to there, under normal working, you should not get continuity, meaning power should not come from ground going up. If you have continuity from here to here, it's bad. Okay, so this would be a bad one. And sometimes you can test the other side, and you would do that. Change this to here. So now we're putting this. I did not bring my tripod, so pardon me. As you can see, continuity on both. Okay, So the screw and the spade both have continuity, so that's a bad diode. So that's garbage. All right, so we're going to be checking one on a microwave. This is a new microwave. And you can click anywhere on the capacitor points, and that's going to give you a reading. All right, so we just touched. You can see, here's a good one. You do not want to have continuity from ground to your capacitor. So he's stopping the power. Diode is just a one-way. So when the microwave is running and when it turns off, there's a certain amount of voltage that sends it to ground, shorts it out, but the same amount of voltage is not available coming back in, so it's not able to come back into the capacitor to damage it. So it's basically a one-way valve. So if this is working properly, it will allow power at a given time to short out but not come back in. Basically it discharges each time the unit is finished using. So that's that on that. You can also check for if the unit is grounded. You would put it to the body and then you would put it to one of the points, and of course nothing. So he's good. Your Magnetron. All right, so we have a test lead on one of the leads on the Magnetron, and we should get, well, we do have a reading, 1.2. Usually it's less than 1, but sometimes because I have the lead on as well, that's going to cause increased resistance. So sometimes it should be less. So let's try. There it is. See? There we go. So less than 1 is good. So be careful when you have these on. It's going to increase your resistance. Also, we're going to check to the body, and it should not be shorted. Okay, so this is a good Magnetron. Now, body to body, of course it's shorted. All right,